Alright, so in this video, we're going to be talking about, as we had previously mentioned in the other one, quadratics. We're still in quadratics. However, this time we're going to be dealing with the roots, graphing by the roots form. Right, and to basically understand this, what you need to know is that we're going to have a coordinate plane. And probably a parabola, right? Remember, a parabola forms this U-shape, depending on A. Let me go over this. If A is greater than 0, your parabola is opening up. If A is smaller than 0, your parabola is opening down, right? Sorry. So this would be here, and this would be here. So if we say we have our parabola, say this is the vertex, and we have it here, somewhat like this. Oh no, this looks horribly bad. Like that. And we have our symmetry here. Ugh, missed it completely. And say we have the symmetry here. The roots mean x-intercepts. Another word for roots means x-intercepts. Intercepts. And remember, we talked about y-intercepts. Y-intercept is always going to be in the form of 0 and y, right? It's going to be here, where it touches our vertical plane. So our x-intercept is going to be x and 0, where our horizontal plane will always be 0, like here. This is one root. This parabola has one root, or one x-intercept, right? Because remember, when we're solving for quadratics, right, going a little bit away from the objective of our video, is always, or if it's in the null factor law, you know that a times b equals 0, right? So it's always going to equal 0, or whenever you're trying to use the basket hour quadratic formula, you know that your a, your b, and your c, for example, if you have 4x squared plus 2x plus 2, would always have to equal 0 in order for you to get your quadratic formula. To plug these values in, right, to your quadratic formula. So what I'm trying to say is that your root, or your x-intercept, will always be the answer for, or the value for x whenever you're trying to solve a quadratic, right? Because that's what you're solving for. So when we're graphing quadratics, we can graph this by the roots. It's not that common as the standard form or even the vertex form, which I'm going to be doing in my next video, but it's still common. So let's go to the formula. And then we're going to do one example using it. Okay, so say we have the formula is y equals, and then we see x1 minus, let's do root 1, being multiplied, right? And this is a, right? So we can't forget a. People usually forget a, but we can't forget a. So it's always a. Remember the a value in quadratics is very important for two things. If your parabola is going to be compressed, right, or stretched horizontally or vertically, and it's always going to tell you if the parabola is going to open up or down. So it's very important that we have the a. And then we have x1, and then we can say minus, let's do r1 be multiplied by x2, right, your second x, minus, no, x1 again, sorry, let's just say my x is going to be x1, now it's going to be minus your r2. And these r's are representing the roots. They're always the roots. Right, so let's do a typical example. Say that we have 2 points. Sorry. Let's do an example where we want to put it in this equation, and then we're going to graph the extra parabola. Say that we have a coordinate point in which it's 4, 7. Right, this is the point that it gives us. It tells us that the parabola passes through this point, or this coordinate, right? And let's say that we're trying to put this into our roots form. In order to do that, we need to know the value of a. First things first, we need to know this value here for a. And say that the value for a is 4. A equals 4. To do that, we're going to have our 7, right, which is our y coordinate. We're going to have 4, And then we're going to have x1, which we said is 4 again. 4 minus roots. Well, we don't know the roots. We need to solve the roots. So the roots would be the x, and then that's being multiplied by our 4 minus our second x. So x2. x2. Right? This would be, this is going to be the form. Your root would be a variable. Your other root would be a variable. You would have your 4. You would have your y. What I'm trying to tell you is that most of the time, you're going to, when you need the formulas, usually you solve for a, right? Because you're probably going to have the roots. You're probably going to have the roots ready. You're probably going to find the value for these roots ready. You're probably going to have the intercepts, the two x-intercepts, and then with that, you're going to be able to plug an x in and a y in to solve for this a. But let's not get too much with that. Let's actually go with the graphing. All right, so let me erase that. So we have y equals 2. Let's not do a. A is not important for this case. Let's see we have y equals x minus 2 times x minus 1. And remember, in our equation, it's always the opposites. So it's going to be the opposite of the numbers in here, right? The absolute opposites. So we're going to have our coordinate plane. And then we're going to have, let's do 1, 2, 3, 4, and 5. Right? And let's do -1, -2, -3, -4, -5. Let's do here 1, 2, 3, 4, and 5. And here's -1, -2, -3, -4, -5. Okay, so what we do is opposite of this root. So our roots are 2 and 1, right? Because it's always the opposite. It's as a negative in our equation. And 1. So for that, we go to our roots. We go to 2. And we go to 1. And 1. Right? So these are our two roots. So what we do is, we know that our vertex is going to be the midpoint between them. Right? And how do you find a midpoint? You do 2 plus 1 divided by 2, in which equals 3/2. So your vertex is going to be, let's say, here, around here. Right? Your x value of your vertex, or your line of symmetry. So it's going to be around here. And then what we would do next is we would plug it in. We would plug this into the equation, and let's say it gives us here. Our vertex would be here, right? A negative value, because we know that our 8 is going to open up. We know this is in the same axis. So what we do next is we connect these 2 points, parabola 1, parabola 2. But you would actually need to plug this into the equation. But I'm not doing that in terms of time management, but let's say that we would actually do. Let's do it. Let's actually do it.